instruction before starting with the online webinar session. Keep your mics on mute. Camera should be off. Do not select present screen and end call in between the session. Post your queries, if any, related to topic only in chat box. Speaker will address the questions at the end of the presentation. As it is online session, it is request to all the participants to be supportive and patient with technical errors or inaccuracy, if any. In case you get disconnected, join in by clicking on the same link again. Thank you. We'll soon start with our session. Good afternoon. A warm welcome to everyone. I request all participants to turn off your camera and mute your microphone. Unmute yourselves only when asked by the speaker. If you have any queries, kindly post in chat box. We will try to address maximum queries at the end of the session. I, Ms. Mokshita Shetty, on behalf of Chikitsak Samuha, Sir Sitaram, and Lady Shantabai, Patkar College of Arts and Science, and Patkar-Varde College of Commerce and Economics, would like to welcome you all for international webinar titled Research in IT, Paradigm Shift in Technology, organized by Department of Information Technology and Computer Science. I would like to first give you a brief introduction about our college. Our college was established in 1964. The college has various aided and self-financed courses at undergraduate and postgraduate levels, along with diploma and certification courses. We are an autonomous college affiliated to University of Mumbai. We are proud to mention that our college has received several awards. Our college was re-accredited by NAC as an A+ college with a score of 3.53 in the year 2019. Achieved Best College Award from University of Mumbai in the year 2016-17. Our college is also an ISO 9001-2015 certified and DBT Star Scheme awardee. We have also got India's Education Excellence Award 2018 from Berkshire Media USA. In April 2020, as per Education World India College ranking, for 2020-21, our college was ranked 45th in all India and 10th in Maharashtra. The Research in IT series of seminar was initiated in the year 2010 with the aim of bringing researchers, professionals, teachers, and students on one platform for sharing knowledge about current and upcoming domain and research areas in information technology. Till date, we have conducted one UGC-sponsored national conference, 2 district, 2 state, 2 national and international seminars. This is the 4th successful year of international seminar. There is a famous quote by Leonardo da Vinci, "Learning never exhausts the mind." Currently, the COVID-19 pandemic situation has kept all of us, that is our students and teachers, out of traditional classrooms. In such situation, these webinars are helping to enrich and equip the teachers and students to transform from offline to online learning. We have our principal sir with us. I request our principal sir, Dr. Shrikant Sawant, to address the audience.
Thank you, Mokshita. Hello, everyone. Good afternoon and a very warm welcome to you all on the occasion of hosting this RUSA-sponsored international webinar on Research in IT, Paradigm Shift in Technology, organized by Department of Computer Science and Information Technology of Chikitsak Samuha's Sir Sitaram and Lady Shantabai Patkar College of Arts and Science and Patkar-Varde College of Commerce and Economics. Patkar-Varde College is one of the premier education institutions in Mumbai's western suburb. Since the establishment in 1964, it has constantly worked at increasing the number of courses it offers students and bettering its infrastructure. The college has grown steadily over the last 5 decades, and keeping with speed of learning and growing, we have set high standards, working continuously towards advanced goals. Today, education from UG to research, commitment to the vision and mission, easy accessibility, and highly dedicated staff and motivated staff have made the college a name to reckon with. The college is a recipient of many awards. Recently, the college is re-accredited by NAC in its 3rd cycle with A+ grade and 3.53 CGPA. The college is granted autonomous status. College is ISO 9001-2015 certified and DBT Star Scheme awardee. We are recipient of Best College Award by the University of Mumbai for the year 2016 and 17, and Indian Educational Excellence Award of 2018 Berkshire Media LLC, USC. Education World India's ranking In India, we are 45th in all India and 10th in Maharashtra amongst the non-government autonomous colleges. It gives me immense pleasure to welcome our eminent speakers, resource persons for this webinar. Dr. Utku Kose, Associate Professor of Computer Engineering, Süleyman Demirel University in Sparta, Turkey. Dr. Hani Kusa, Assistant Professor in Computer and Information Science, Department of SCT, Dubai. I also extend my warm welcome to our trustee, Honorable Sri Kishorji Rangnekar, President of Chikitsak Samuha, Sri Rajesh Desai, Vice President, Dr. Gurunath Pandit, Joint Secretary, Sri Girish Amonkar, Joint Treasurer, and all the office bearers of Chikitsak Samuha. Dr. Malakharkar, CEO, and the organizing team of Computer Science and Information Technology. This webinar on research in IT, paradigm shift in technology. We know in pandemic situation, the things are being changed. Everything is changing from offline to online. And therefore, the role of IT and computer science has become very vital in connecting the people. We have paradigm shift in technology. Technology is constantly growing, constantly changing. Therefore, there are a number of researches are being done. There is a vast field of research in IT and computer science. Because in the pandemic situation, for each and everything, we need IT persons, we need computer science persons, and they need updated things, growing things. Therefore, research is must. Research is very important. Without research, we cannot go ahead. Research takes us into altogether new world. And I am quite sure that we have eminent resource persons, Dr. Utku Kose and Dr. Hani Kusa, these speakers will throw light, give us insight, and they will open several avenues for the researchers, teachers, inspiring persons in the IT sector and computer field. I wish all the best for this webinar. And once again, I would like to welcome all the participants, resource persons to this webinar on research in IT, paradigm shift in technology. We must play with technology, we must learn with technology, and we should go ahead with technology. Technology is the only source nowadays for us. With this, I now hand over to Mokshita. Thank you.
Thank you so much, sir, for letting us know how technology and research go in hand. With this objective, I would like to hand over the session to my colleague Neha Adnani. Thank you, everyone.
Thank you, Mokshita ma'am. Moving forward to the first session of the day, I, Ms. Neha Adnani, would now like to introduce you all to our keynote eminent speaker, Dr. Utku Kose. Dr. Utku Kose has completed his DS PhD in Computer Engineering from Selçuk University and MS degree in 2010 from Afyon Kocaeli University, Turkey in the field of computing. Dr. Kose has over 10 years of academic work experience. In his career, from 2009, he has worked as a research assistant, a lecturer and vocational school vice director in Afyon Kocaeli University, as a lecturer and research center director in Usak University, and as an assistant professor in Suleiman Demirel University till 2019. Currently, he is an associate professor in Suleiman Demirel University, Turkey. Dr. Kose is also one of the series editor of the Biomedical and Robotics Healthcare series by CRC Press. He has more than 100 publications, including articles, authored and edited books, proceedings, and reports, and his research interests include artificial intelligence, machine ethics, artificial intelligence safety, optimization, Chow's theory, distance education, e-learning, computer education, and computer science. It's a great pleasure to have you as a speaker today, sir. I would now request the speaker of the session, Dr. Utku Kose, to enlighten us on the topic IoT solutions in COVID-19. Over to you, sir.
Thank you very much, dear Neha. I think you all, everybody is seeing my view on the camera, and also you are also hearing my voice. I would like to thank again for the kind invitation to hold that international webinar on IoT technologies in COVID-19. I'd like to also thank to Mokshita for the introduction and also a very kind and informative speech by Professor Savant because he has explained the situation very well in terms of especially the time we are currently experiencing because of that the COVID-19 situation and because of that the massive pandemic, worldwide massive problem. Things are changing as the Professor Savant has just mentioned. And because of the changing conditions, changing things, we should reshape the way of the technology for communication, for solving medical problems, and many other things associated with the use of, for example, the artificial intelligence, and also any other smart technologies rising over different communication technologies, and also the data analysis technologies. Yes, my topic, my speech is based on the IoT technologies for as a solution for the COVID-19, and I would like to present my screen first of all. I think you are now seeing my desktop. Yes, let's pass to the presentation. I'm starting my presentation file. Yes. As you can see, my topic is associated with two essential topics, which are Internet of Things, you know, as the IoT in a brief, as a brief word, and also we will be considering the solutions which we are using or will be probably using for combating against COVID-19. My friends, colleagues has already introduced me very well. Thanks again for especially Neha and Mokshita for introducing me, and also for Professor Savant again. And as you can see, I'm an associate professor at the Suleiman Demirel University and the Department of Computer Engineering located in the Sparta city of the Sparta of Turkey. You can see my email addresses. You can reach to my for any information or any other questions after viewing the webinar session. So you are all welcome to contact me. And also you can visit my website, personal website with my name and .com. I have not mentioned it here, but you can visit my also personal website for many other things and news or other articles. For example, I'm writing in some days, and also you can reach to detailed CV and other information regarding my research interests. So you can shape your own academic way in terms of, especially, for example, artificial intelligence, because it's my expertise, and also other things related to smart technologies, for example. So you are all welcome to visit my website and to contact me for any questions after even the webinar session. Yes, my presentation will be divided into 6 main titles, and after that I will take your questions. Any questions, you are always welcome to ask any questions at the end of my webinar. So I will just make a brief introduction to the concept of the artificial intelligence at the start, and after that I will also explain some about the subfields of artificial intelligence. And by moving from them, I will just make a connection to the concept of the IoT and technology of IoT. I will also explain the ambient intelligence. I don't know if you have heard about that concept, but it's known as a new concept. Actually, not a very new concept, but it's a very important concept in the intersection of Internet of Things and also AI. And I will also explain some about that concept. And after that, I will just give some information about COVID-19, so we will understand why we should be using IoT for combating or for dealing with or trying to eliminate the COVID-19 from world, from the earth. So after that, I will take your questions. Yes, my friend Neha, dear friend Neha, has already introduced me, so I will pass that slide. But you are always welcome to visit my also academic profiles to learn more about what I'm doing in terms of academic and scientific works. So that's all. You already heard about my background in terms of especially academic works. I'm currently working in the Süleyman Demirel University, Sparta, but before that I worked in two different universities. I visited Italy for a while before that, and currently I'm an associate professor at that university for now. We will see what the time will bring, of course, in the following time period, but I'm currently there. And also, let me to introduce briefly about Sparta and Afyon, which is my hometown also. As you can see, these both cities are very near. I was born in Afyon, and my Bachelor of Science degree was from Ankara, which is the capital city of Turkey. You may already hear about Istanbul, but there are lots of beautiful cities in Turkey, so you are all welcome to visit different sides of Turkey, especially, for example, seaside. You can see there are lots of different cities. And if you want to visit Sparta, we are famous with roses and also green areas, and also some lakes, which causes the region of near to the Sparta, and some cities are called as the region of the lakes. So you are all welcome to visit the Sparta, the city of Sparta. And you are also welcome to visit my hometown, Afyonkarahisar. It's famous with the wars for the independence wars of Turkey. You may know it's the city where the independence war of Turkey, Republic of Turkey, was started. And there's a very old castle, big castle at Afyonkarahisar. So you are all welcome to visit Sparta for roses, for lakes, for green areas, and Afyonkarahisar for its historical background, very deep historical background, and also lots of different beautiful sightseeing. You are all welcome. And when I would like to talk about my university, I can say that it's a public university, the STU, or we can say Süleyman Demirel University. And Süleyman Demirel is a former president of Turkey, and he was born in Sparta, so that's why we call that university with his name. It's a public university located in Sparta, Turkey, and because of the roses, as you can see, there is the logo sign again over the logo of that university. When you visit Sparta, you will see probably lots of roses shops, and everything is associated with roses, and you may feel bored about roses after a while, but it's even located on the logo of the university. And the STU was established in 1992, and with around 70,000 students, it's known as a large academic institution in Turkey. And our university is known for its programs in agricultural research, medicine, engineering, and business science. And when we comes to my Department of Computer Engineering, it's located in the Faculty of Engineering, and we has currently 3 professors. and 2 associate professors, as I am the one of them. And we have also 8 assistant professors and 2 research assistants. And our department is divided into 3 different areas of computer science, computer software, and computer hardware. We currently have the Bachelor of Science, Master of Science, and PhD degrees, and we also host many different international students from different countries around the world. So you are all welcome to visit our department, our university, and also, of course, you are all welcome to run some degrees in our department. If you have any questions regarding that, you are all welcome to ask me after the webinar session. So that's all. Yes, start to talk about more technical things or the things regarding my presentation, my speech. We can see that the AI, the field of AI, is a very widely discussed and examined topic for nowadays. It's known as the technology of the present and the future, as you know. And the father of that concept, Professor John McCarthy, calls or defines the concept of AI briefly as the science and engineering of making intelligent machines. That's a very brief and pure definition, but you may also encounter with many different definitions over the web. But actually, we can say that there is the science, there is the field of a subfield of computer science. And in that field, that subfield, we just deal with some theoretical and applied things, which can be associated with making or designing, developing intelligent machines, which are able to solve some problems of the real world. And in that way, we just come to a future which is which can be shaped with technological tools, unmanned tools, and tools without contributions by humankind. And that's, of course, all widely discussed if the AI will be a technological risk or threat for the humankind. And there are lots of many discussions regarding if it will be a utopia or dystopia. And we cannot say that it's a science without human, because it's the product of the humankind by the humankind. And we cannot say it will be or not cause of existence, because in theoretical means it may be possible, but in terms of technological things which are affecting the applied things, it's still seems impossible, because the field of AI should be taking more steps in terms of technological components to be able to think by itself better and to think about the existence of the humankind and the world or the other living organisms. So in theoretical means it's possible, but in applied manner it's not possible for now. And we cannot say that it's a science by evolving by its own efforts, because there are lots of different supportive technologies. I will show them in my next slides. And it seems like not a stoppable technology because of the developments and advancements in different supportive technologies. So we can say that the field of AI has a great potential in terms of present, not only present, and also for the future. And we can say that it's somehow a simulation of humans, animals, and nature. Just think about the algorithms and coded programs in your computer systems or in your just smartphone. It's such programs are all just some organized codes for solving some certain problems. But when we come to the field of AI, we can say that there are lots of the different algorithms which were based on, or which were developed as based on the mathematical and logical things, and also some multidisciplinary approach to build up some inspired sets of codes as inspired from humans' actions or behaviors by humans, animals, and the nature. And we can say that it's very famous because it's allowing the more effectiveness and efficiencies in real-world problems. We can say that it's, of course, a technology-based intelligence solutions, a set of intelligence solutions rising over technological components. we can say is that it's a very widely spread multidisciplinary science. With the start of the 21st century, we can say is that there is no field where the artificial intelligence-based solutions are not used, because it's very widely used in all fields of the modern life. And we can say is that it's an interface between human and the machine. Just think about robotic systems. Because of that, the AI is just an interface for controlling the machines, controlling the robotics, for solving the problems in an automated manner, and also providing more effectiveness and efficiencies in our real-world problems. When we come to talk about the subfields of AI, we can say is that mainly the field of AI is divided into two different main topics, which means the algorithms with learning capabilities and the algorithms which do not employ or doesn't employ an algorithm which doesn't employ learning steps. Which means we can say the machine learning is actually the subfield of AI, as combining all of the algorithms with learning capabilities. But as I've said, not every types of artificial intelligence techniques have the learning capabilities. So, for example, for the optimization algorithms inspired from nature-inspired algorithms or evolutionary algorithms such as genetic algorithms are not using the learning steps, but they are just using loops to find out some hidden values or some unknown values of some variables associated with mathematical models to solve the target optimization problem. And we can say that there is, for example, the fuzzy logic, which is used for adaptive control and doesn't employ any learning capabilities. But all of these doesn't mean we are not supporting the algorithms. We are just modeling some mathematical problem, and we are just, for example, modeling some rules and also some fuzzy logic oriented knowledge base. And by using them, we are just enabling the algorithms to run some solutions without needing learning steps. And also, when we come, for example, cybernetics, we can say that the cybernetics is just a combination of medical and electrical and mechanical engineering-based solutions for improving our capabilities of living organisms, or just supporting them with some components which are able to enable us to gain some additional capabilities. For example, just using some cybernetics built lenses, you just gain some night seeing night sight capabilities to see everything in dark places, for example. So that explains the subfield of cybernetics. And when we come to machine learning, you may already heard about deep learning. Deep learning is actually is another subfield of the machine learning. Actually, some sets of more advanced neural networks which are using the big data or complex form of data to provide better robust solutions for your real-world problems. That means that machine learning is actually a very successful subfield with learning steps, and after that using the learned techniques for your problem. But after a while, some problems because of the improving amount of the data, which means big data, for example, and the speed of the growing data, which is also again another feature of the big data. Just machine learning algorithms have become a little weak in terms of providing effective solutions. So because of that, some advanced forms of neural networks were built, developed in time, and because of using a deeper solution sites, we call that new field Actually, I think it's not very new for now, but by considering the other techniques of artificial intelligence, we can of course say the deep learning is a new subfield of the machine learning, which is also again a subfield of the AI. And deep learning is one of the most currently widely used solution sites of the artificial intelligence. And by moving the artificial intelligence, we already build up, the humankind has already built up some associated technologies, which means smart tools. And that brings us to some different solutions, and the Internet of Things is known among one of them. But before talking about Internet of Things, I would like to provide a bigger picture of the artificial intelligence and the associated different supportive technologies. As I've said before at the start of my presentation of just a few slides ago, we can see the AI as in the color of the yellow. And as you can see, the machine learning is subfield of AI, and the deep learning is the subfield of machine learning, which means we cannot say that every algorithms are also machine learning, but every machine learning algorithms is also artificial intelligence algorithms, for example. And also we can say that every deep learning algorithms are also machine learning algorithms, and also all deep learning and machine learning algorithms or techniques are known as also artificial intelligence based solutions. Sorry. And we can say that there is the data mining. Data mining has actually some intersections with the AI. And data mining is actually just focusing on the way of the data by using some analysis and other things to derive some hidden patterns or just make some transformations over the data. And the AI is just a popular name which enables us to understand the inspiration side of that technological field, and also it's we can understand from the artificial intelligence the way of the solution which is inspired from the natural intelligence we know from humans actually. And of course there are many other living organisms that may having some intelligence at least. And because some of the techniques in data mining are not actually, for example, association rules and a priori algorithms are not actually somehow artificial intelligence based techniques. So because of that, there is the intersection between these two different fields. And as you can see, the cybernetics is in the AI. And as you can see, there is the robotics. Robotics is actually associated with the electronics and also data processing and maybe communication and many other engineering fields like mechanical engineering or maybe chemistry, because we know about some soft robotics for now, for a while actually, which means using some soft materials to make some robotic systems which are not using hardware actually, but using some soft materials to be able to reach to different fields of the real world, which are not very possible for hard robotics to reach. So the robotics field is also associated with many different fields. But as you can see, these fields are generally some of brief supportive technologies which are near to AI, but you can just make an extension of regarding that the view. So I would like to just make a brief view to the, for example, electronics, communication technologies, robotics, or data mining, which we already know when we talk about AI, but you can just imagine a bigger picture about that view. And also we know about data processing, which includes, for example, image processing or signal processing, which are used for making the work of AI easier for solving real-world problems in a better way. And we know about communication technologies. Just think about internet or web technologies. We already know about them, about all technological developments. And we already know about electronics. Just think about computer and communication technologies, which are not which couldn't be have developed without having electronics and communication technology developments, for example. So when we talk about communication and electronics and also some about AI, we just reach to the concept of Internet of Things. You may already heard about that technological component. It's actually the technology of the future, but currently we are, as the humankind, we are already experiencing the effects of IoT by just considering, for example, an iPhone mobile device, because it has lots of sensors and other components in terms of software. So iPhone or smartphones are actually among very common, very widely known and used IoT components, for example. But IoT is not just mobile phones, of course, mobile technologies, but it's just a combination of different technological components. And we can say briefly that it's a communication network of physical devices with deeper abilities in terms of data processing. We may think about software background, of course, but when we talk about the exact thing, we should just talk about physical devices and their communication network, maybe worldwide or in a wider network with not just a local network, for example. And we should just talk about deeper abilities in terms of data processing, which means use of AI, use of smart approach to analyze some data. And because of that, IoT is the cause of smart technologies, and it aims to ensure effective interaction of human to human, which means an indirect use of technological devices, physical devices under the umbrella of the IoT, in order to achieve some human-to-human interaction in terms of indirect touch. And also we can talk about the human-to-computer interaction, which means we already interact with computers. For even now, we are all communicating by interacting with the computer system. But human-to-computer interaction is now means in a deeper and smart manner approach thanks to IoT. So we should talk about which components are causing the rise of the IoT, the Internet of Things technology. We can, for example, talk about embedded systems. The IoT couldn't have be real without having embedded systems because they have caused the technological components to become smaller and embedded by employing some smart capabilities in terms of data processing. And we couldn't have talked about IoT without having wireless sensor networks. It's a very widely discussed a topic which is widely researched by researchers worldwide. And without sensors, actually, we cannot talk about IoT systems, for example. And without cloud systems, the cloud computing, we cannot talk about data processing after use of wireless components, for example. And of course, there is the AI side, which means we do not just directly use some devices to ensure communication, but enable them to perform some smart data processing phases to make the better understanding of the flowing data to ensure less interaction or less control by humankind, which means automated and autonomous systems which are communicating each other and sometimes enabling humans to contribute maybe, but in terms of wider feature, we just talk about some smart environments, smart cities, smart campus, smart buildings, smart environments, and we just talk about the IoT systems thanks to all of these communication components and also data processing, which is made smarter thanks to AI-based solutions. And we just we should be talking about control approach and automation, which means we always should be talking about automation and controlling approach when we talk about robotic systems or some intelligent systems running in a factory, for example, because all of these are possible thanks to just automation and some controlling approach. So all of these abstract concepts and some strategies regarding all of these both concepts are associated with roots of the IoT. And also, of course, we come to data science, which is important for even AI, for even other components, because the data flowing around the world is not a processed data. Actually, it's all called as unstructured data. Sometimes, of course, we just use some components and smart technologies maybe, or just some electronic devices to gather some structured data. But actually, more amount of data is unstructured. So because of that, the data science should be used for making the work of AI easier and to make of other components easier. For example, sensor networks to make their works easier. So we just reach to the better form of IoT, which is just a network of smart devices talking each other. And you should be already hearing about wearable, for example, technologies like smartwatch or other things to wear to gather some, for example, some data, for example, some health state about you by using body area sensors, and by just using some smartphones or other internet connected gateways, we just interact, or our devices just interact with the cloud or big data support, which is located in the concept of the cloud. And thanks to that, we just build up some worldwide technologies to learn more about or to get more information about our health state and some predictive approach to know more about the environment surrounding us around the world. So by running such tools, such IoT things, IoT-oriented things, we just reach to some effective solutions which are just covering some smart components to build up the future of the technology of the world. We just come to a smart future thanks to all of these components. And it's important that we also just should be talking about what is the impact of that, for example, the IoT. We should be just talking about wearable technologies or other, for example, just virtual communication technologies, which means we should be talking about some smart components which allows the volume and the value of that IoT market in the future. For example, some CCS Insight Global Wearable Forecast considers that smartwatch, smartphone components, companies, and also virtual and augmented reality headsets will be very widely used in the time of that till the or starting from the 2016 till 2020, and the device sales will be probably more improved in time. So that means the IoT will be gaining more and more value in time. Just a minute, dear friends. I will just make the plugging in my the charging. Sorry for that, because I just forgot about plugging in that. Yes, everything is fine now. And we should be just talking about that 2020 just is the beginning of the rise, the value of the IoT, but the future will be probably more and more employing widely used of the IoT technologies. And because of that, we can just see some people like that wearing some glasses, some smart cameras or other smart watches or wearables going around the world. So we will just, in the next slides, we will just talk about that in terms of effects dealing with the COVID-19. So wearables are very important. And when we talk about growth in the Internet of Things, IoT, that's just some predictions regarding 2020. I didn't count the exact number actually, but according to that data, predicted data, by 2020, the number of connected devices, smart devices, seems to be exceed 50 billion by 2020. So we can see there is an exponential growth in terms of using IoT components. So that just informs us the steps, very noisy steps of the future, with including smart technologies. But of course, smart technologies are actually built up over some other components that I just showed here. And maybe it's another topic to discuss in another webinar, maybe the role of AI techniques. For example, we may be talking about the use of fuzzy logic or other components, maybe deep learning, to understand better about their effects on rising advanced forms of IoT, because you just form some strategies to build up some better forms of IoT systems to ensure better data processing and better understanding of the data to better provide effective solutions for the humans, for example. And why I'm talking about that, that's important because we should also talk about the ambient intelligence. Ambient intelligence is actually an intersection, a concept taking place in the intersection of Internet of Things and artificial intelligence. And one of the most critical way of using that ambient intelligence is just not showing their exact smart background to us, which means we just, as you can see from the picture, we just will be living in an environment like a smart home, for example, and thanks to many other components talking each other, communicating each other, there will be a smart environment which is controlling our health state, which is controlling our safety, which is controlling all the well-being of the maybe home environment, for example. But all of these things are just done by not making all of these components to be seen or to be controlled or to be managed or to be just technically controlled by humans, which means just like a common objects of the real world. And of course, thanks to maybe probably 5G or 6G, because of the advancements for rapid communications infrastructures with wireless communication background, such components will be more common thanks to ambient intelligence. And ambient intelligence is actually also includes more more use of the artificial intelligence with more amount of data processing done over artificial intelligence based techniques. So ambient intelligence is just another different new concept of AI, which means the use of objects surrounding us and making our life easier or more practical. And of course, we will see for the future if that will be okay or not. And when talking about IoT, we can also talk about IoHT, IoMT, which means medical or health side of IoT. Also, there are some other subfields, for example, IoT data analytics, which means IoT DEA. For example, and rising some subfields under the umbrella of the field of artificial intelligence, we will probably see different IO and T with different addition of different letters from the alphabets to better explain the scope of the IoT components like health or healthcare or medical environments. So when we come to COVID-19, we should, first of all, we should just talk about what is the COVID-19. In terms of medical view, of course, we can say more things, but in terms of the situation we are just experiencing as the humans, we can say that COVID-19 is a disease with still unknown characteristics and functions. In time, there are lots of advancements and more things appear to be known about COVID-19, but we still have some unknown things about it. And we can say that, of course, it's a very rapidly spreading problem and massive problem with spread just with a small interaction among people or animals and people maybe. So because of that, it's a massive problem for now, which we called as a pandemic. And also it's a problem with symptoms hitting different diseases too. So we should just make a deeper analysis to make it sure that that the patient has COVID-19 or another disease that he or she just have. And we can say that COVID-19 is a strong virus type. If it would have not very strong like that, we shouldn't have been talking about it for now, for example. And also it's a very important social problem. It has affected many things, as Professor Sawant just mentioned at the start of the session. Many things are changing, many things are changed. Everything is changing in time, and that's because of COVID-19. And not only the technical things are changing or use of technical things or experiences regarding technical things are changing, but social things are also changed. For example, we are just working remotely at homes. We are just trying to have some physical distance among people, which causes some problems about social interaction, I think. We just try to make interaction over smartphones, over social media, and it was already an important problem if you are not using social media very well or for your well-being, for example. So the COVID-19 has made it possible to make more distance among social organisms or humankind. So because of that, it's a social problem. And it seems like a still not ended problem, or we can say that it may be a long-term pandemic, and maybe because of some future pandemics, of course. But of course, when we talk about some solutions in terms of COVID-19, we can say that it's a problem that can be tracked with data. Because of that, there are lots of big data-oriented research works. There are lots of visualization components over the web to understand from which place to which place it is just spreading in real time, for example. And by just looking to news and some social media environments, we just track the rise or the treatment of the COVID-19. So we can say that it's a problem that can be tracked with data, and it's a problem that can be understood via big data, data science, a deeper analysis of data, and it can be understood via intelligent tools, of course, which that brings us to IoT and artificial intelligence-based systems. And also we need innovative technologies which should be developed and invented to make that problem to be better understood, of course. And we can say that COVID-19 is a disease that can be treated somehow. As the humankind, we are still currently working on how to treat it. There are lots of works regarding for example, treatments and the drug discovery, vaccine discovery, but we will, of course, see what the time will be bringing in time. And when we talk about IoT, that's the exact thing we should be just hitting. The IoT can be used for example, in terms of wearables for tracking human actions. We just use some smartphones, GPS, for example, to track human actions, to movements by humans. By just using wearables, we can just have more deeper analysis of, for example, health state of humans. So thanks to that, we just take IoT for ensuring better solution for COVID-19, or better tracking, at least for preventing from more spread of that virus type. So there are lots of some research works regarding not only just using smartphone or social media data, but it's already done think for a while, understanding about what people are actually doing. But wearables are very critical to build up new things, to make better tracking of human actions and health state, for example. So that brings us to use of IoT for building up smart systems for better indirect healthcare, which means while you are just staying at home, some IoT systems may be located in some places, and they may just tracking your movements, and thanks to some wearable or smartphone oriented tools that they may be just tracking your health state. Of course, there are some lots of discussions about privacy of personal data, but by just making some policies, ensuring some policies, that may be a better solution in terms of IoT and its effects in dealing with COVID-19. And of course, smart telemedicine systems may be effective. There have been very widely used telemedicine systems for a while, which means just making some remote interaction between medical staff and patients, for example, or communication between different medical staff living at different regions of the world. But when we talk about smart telemedicine systems, we just talk about some indirect use of AI systems to make better understanding of the people you are just talking about. Just think about the movie that's Terminator, or other movies, just showing some waves from the robotic system, just flowing some data on the view of your eyes. Or just think about Google Glass, maybe just some augmented reality based systems, just data and information are just flowing in your eyes and your view. And thanks to such components in telemedicine systems, there may be more advanced form of such systems, just by giving some brief information about the patient you are just talking about, or while just talking with the medical staff, you may just receive some ready instructions or other things to make you better understanding what is actually the medical staff is talking. Of course, just think about real-time translation systems located inside of the smart components, smart mobile device maybe. Thanks to that, you can be talking with a doctor at, for example, Canada or USA without knowing actually English, or you may be talking about a doctor from China or Japan by not knowing Chinese, talking Chinese or Japanese. So thanks to that, the telemedicine systems may be improved greatly. And we maybe talk about ambient intelligence, which are indirect use of for well-being. We may talk about massive tracking systems for healthcare by just tracking everything worldwide by data collecting, which is done again by IoT systems for better data collecting, for example. Actually, IoT is not just data processing, but it may be just used for effectively for data collecting by just using some smart ways. I mean, like just going to the real world and just collecting everything you see. It's not a true wave. You just collect maybe some food, for example, to give some animals to dogs or cats, and that's more reasonable thing to collect things from the real world. It's a smart way because you have just an objective and just you collect some things regarding that objective. So just by thinking about that, we can say that the IoT can be effective data collecting tools for real-time tracking of the COVID-19. And we just ensure that with wearables, of course, or telemedicine systems, just think about that the combinations of all of these different scenarios. And we can talk about distributed safe systems for medical data share. Just think about blockchain or IoTA. IoTA is another data model for especially IoT systems, because of that concept is very similar in terms of reading and writing to the IoT. And thanks to IoTA or blockchain components, we can ensure safe systems for medical data share. So everybody may be feeling better or trusted in terms of sharing their private medical data with different environments or hospitals or medical systems, for example. And also we can talk about distributed data processing with only mobile systems, which means smartwatch and mobile devices, which means making data flow effectively with just small components which we can carry while living at home, while working remotely. And thanks to that, we can be better combating COVID-19. And we can also form worldwide diagnosis and treatment synergy with smart tools, which means ensuring communication with devices and ensuring human-to-human indirect communication, and contributing to rise of or design of different diagnosis systems, early diagnosis systems, or treatment strategies thanks to IoT. And also we can build up some precaution approach by using such smart tools. And finally, of course, by using IoT, by using the data collected everywhere, because the IoT has the ability to take place everywhere, at home, at the streets, at the hospitals, at different environments. So thanks to that, we will be having just a very useful and small place taking tools to share every kind of data from the real world, which is chaotic, of course. So thanks to all of these data, we may be also able to derive some future components, future technologies to detailed analysis of future possible disease or pandemics, or maybe predicting some important problems in terms of social problems, in terms of communication, social problems, and also medical problems, by considering the effects of COVID-19. So COVID-19 and the intersection of that problem with the IoT is actually another step for making the growth of IoT better and better. That will be probably giving more advantages in terms of not only dealing with COVID-19, but also understanding the world better, or making the world more practical and easier for us. But as my final words, I can say that we should be aware of that more use of technology may be not very good for the natural characteristics of the human and also the living world and living organisms, including animals and flowers and plants around the world. So I don't know if such technological components also cause of rise of such medical problems, but we should be having some balance between the technology use and between the way of the world we are just experiencing, so that we will be living a better future for the new generations. Yes, that's all. I hope you have not felt bored because of the many things, many explanations I have done. I can take your questions. I'm just making the presentation to be stopped to be better seeing your questions. Of course, thank you very much for listening to me. I hope the presentation has been enjoyable for all of you. So your questions are all welcome. I'm just taking a look at to the message, of course. No, there are lots of questions or discussions in the chat area. Dear Divesh, I just gave some examples of IoT to this pandemic year. For example, the more use of wearable devices and smartphones, of course, while we are taking place at our homes, we may be better in taking better place in terms of sharing data and enabling both researchers at both medical and the other technical sides of the, for example, the research components of that dealing with the COVID-19. So we may be just also thinking about the software systems, software solutions. Maybe that's another important component, because while we are living in a world with without going to work, going to universities, going to making research works, for example, we may be just thinking about some developments of software systems to make or to improve data processing capabilities of our devices, because smartphones or other computer systems has already such background ready to run. So by using them, we may be making everything better in short time periods, maybe. And what is control approach? Control approach means, for example, you may just run some physiologic oriented algorithms. I'm just answering to the question by Priya now. You may just some fuzzy logic or some knowledge-based systems to control the flow of the data among the IoT components. And also there are some data processing and data flow algorithms. For example, you may just use combinatorial optimization by just using some algorithms such as ant colony optimization or some other algorithms to make the better flow of the data, which means you just ensure some construction in the roads, and just you immediately make some adaptive direction for the cars moving, for the trucks moving along the roads. So in that way, you may just run some smarter ways of control approach for IoT. And dear Parts also asked that what is random forest and what is the role of random forest in AI. Random forest is a machine learning oriented algorithm. Is just inspires from just some growing forests in the nature to make that the more grow of, as a metaphor, of course, the more growth of the data processing components, which are just logically represented by some mathematical calculation components in terms of your real world problems. You just run some optimization and machine learning oriented steps to find out a better solution for your real problem by just, for example, running some groups of students to make which group of students will be better successful in terms of solving the problem. And by just running all of these groups of students, you just make them to be interacted each other, so they are sharing their problem solution knowledge, which means synergy, of course, real-time synergy. So in that way, you just reach to the solution. At least we just think that it's an optimum solution in a faster way. and in an effective way, which we cannot make with traditional mathematical calculations, or just take some more time to reach to the solutions. So random forest is among all of these solutions, and it's a recent solution as a widely researched topic. But of course, in terms of machine learning, everybody suggests to examine, to research neural networks at first, because the deep learning even includes advanced forms of neural networks, which means neural networks is, I think, according to me, is the most important and famous and effective techniques of machine learning and artificial intelligence. And by using neural networks, it will be possible to direct all of these IoT components in terms of organization and management of them, targeting the problem, which means COVID-19 or other things, maybe just organizing the robotic systems around the factory maybe. So that's exactly the main solution of, or organization of the solutions for your target problem. And a common operating system will be enabled for every smart devices. Yes, it's dear Mayur, thanks for your question. It's a important question, because a common operating system which is more able to make a better solution for IoT enabling devices may be good for universal solutions, because that will be a necessary thing for the future of the world, because one of the most vital problems of transmission of data and communication, as you say, for faster communication or for better understanding of each device among all of these real-time data flow, we need some common and default communication channels and software systems for faster results, for better results. Because while using current devices, you may just use some middleware software or some components to make transformation of data, to make the target device to understand better of the data coming from another device. So that causes some interruptions in terms of time. So we need operating systems and maybe some more commonly used components. Building up some hardwares, common hardwares is an easy task, but developing some software is a very complex problem. So there should be some policies, maybe some establishments between maybe China and USA oriented companies, maybe, to build up some common solutions for better worldwide IoT communication around the world. Yes. And yeah, Google would replace Linux kernels in Android devices. Yeah, that may be possible, dear Mayur. Yes, yes, by Google that was already started, as Mayur, dear Mayur said that. And can IoT replace completely human mind and take its own decision? Dear Sonali asks that question, dear friends. Yes, IoT, but not IoT. That's exactly the AI we should be talking about, if it will be replace human mind and take its own decision. IoT may be just some real objects, making that easier, thanks to interaction done via human maybe. So we should, first of all, we should talk about or think about AI factor, the abstract factor. The real factors, hardware factors, just will be some real objects to make that happen easier, maybe by just increasing the interaction scope, which we can say is that. Yes, Bluetooth Low Energy Protocol. You may, dear Part, just talk about for example, beacon systems. Beacons are very low energy systems, and they just use Bluetooth protocols to ensure cheaper and faster communication. So beacons are important, dear friends. I'm not just discussed about details of sensors and actuators, for example. So you may just examine them over the web, just search for sensors and actuators for IoT, and you may be reaching to many different types of sensors. But you already heard about them, I know. The sensors are very important components of IoT, and Bluetooth low energy protocols and maybe more new things in the future will be effective for that solutions. Yes. Dear just ask about their day-to-day life implementation of IoT. We may just think about just mobile applications running augmented reality maybe. And we may just think about, for example, iPhone. iPhone just use some data, medical data gathering tools, for example, to make tracking of our medical state, or you just use some mobile applications to track, for example, your running activity, or just tracking activity around the streets. Maybe just because of the COVID-19, it's maybe just not possible always because of lockdowns, but that's another way of the IoT. And also around the world, there are lots of sensors. For example, in university campus, you may just use some sensors to track movements by students, or just taking their attendance sheets, for example, as one of our friends just right there, dear Anurag just wrote over the chat section. We may just use such like that. Just think about the mobile device and sensors. Everything is possible. Almost everything is possible. Yes. And I'm just looking at different questions. Yes. Thanks for your positive feedbacks. By the way, thank you very much, dear friends, for your contribution to our session. And one of dear friends asked that data science with machine learning and deep learning, how we relate them. Dear Professor asked that, Professor Jadav. We just use data science to make machine and deep learning tasks easier. They are advanced forms of data processing. They always need better filtered types of data. So data science just uses better filtered data, or better gathered or structured data, just before feeding them to the machine and deep learning. Just think about some data coming from everybody, every social media network. Machine learning or deep learning cannot be understood them, or maybe just needing more time to understand better about solutions. So data science just makes some pre-processings like feature extractions or other things to make everything easier for such learning algorithms. And also we can again use data science to derive some hidden patterns from data to make new types of data for better understanding of machine and deep learning for problem solutions. Which API can be used for neural networks, Keras, or for machine learning? I suggest Keras and also TensorFlow, of course. Yes, because it can be imported from TensorFlow. You may take a look at, dear Mayur, take a look at to the scikit-learn over the web, and also take a look at to the Colab by Google, which is using TensorFlow. But I think the TensorFlow is the most effective and popular and widely or rapidly improving component for Python and for running as a library for AI-based solutions. And dear Mayer also asked that how might IP version 6 internet address implement on IoT? Because of every components of IoT, including mobile devices and other physical devices, everything should be addressed via IP numbers. So because of there are lots of billions of devices, the IP version 4 is not enough for covering all types of devices. So because of that, IP version 6 just gets two additional components to increase the total numbers of different devices to make every devices around the world carrying IP numbers, which means better control and better tracking of even a refrigerator in terms of smart environment, and also mobile devices, or just camera taking place in streets or at your home. And what is the difference between wireless sensors and IoT? Wireless sensors is actually, it can be understood from the name, they are just wireless the sensors which can be communicated in terms of wireless technologies. And they are components of IoT technology. We just use wireless sensors, we just use cloud, maybe AI, maybe control approach, as I've said before. We just come to reach to IoT. So IoT is a bigger concept, including the components of wireless sensors. Yes. Strong and weak AI. What is the difference? Weak AI is currently the currently experienced forms of AI, which means not very deeply analyzing problems by just running some intelligence components like humans just run. And strong AI means artificial general intelligence or explainable AI, which means we can be running our intelligence systems to just providing something regarding the problem, and it can be deriving some solutions by reading something, by sensing something, and after that running the exact solution. But for now, we just use weak AI, narrow AI, or just we should be forming the exact problem for the AI system, which means our systems are intelligence systems for now are not very intelligent to derive, to understand running or designing new problem solutions. The human is actually the component designing the solutions itself for AI systems, but the future, maybe around 2040 or 30, we will be probably having, at least in terms of theoretical works, we will be having artificial general intelligence, which are able to deriving problem solutions before running their solutions. Yes. And what are suitable databases for IoT? Maybe some already known database systems will be effective for always IoT systems, but maybe like some lightweight database systems will be effective for IoT. And thanks to cloud systems like Amazon Web Services or other things, the database, not only types of database system, but the way of the interaction with the database will be more important for being suitable for better IoT in the future. Yes. How might internet address effect of development and implementation of IoT? Dear Divya asked that. It's the internet is the way of the communication, so the way of the internet and the change of the internet will be always affecting the implementation of IoT. If I understood the answer, the question well enough. The other question, I couldn't understand the IIoT, IoHT or IoMT are related to just medical or health states. If you are talking about internet, I cannot understand what is the I, the first I means in your question, dear Divya. If you can write that in longer as a word, I can answer that question better, so I am passing it. Difference between the wireless sensor network and IoT, dear Sayamuddin, I answered that question. I answered the question by about the IP version 6 by Sonali, of course. In terms of data security, dear Pireya, there are lots of different things, as I said, blockchain or IOTA maybe, and more use of cryptography to make the data privacy security better. as I've said before. Yes. How about PyTorch? PyTorch is an effective way to write Python. You can use Nikhil, dear Nikhil. It's important. Scope of computer vision, yes, you can go for computer vision, but you should be using better collaboration of different components to make better real-time vision flow in the real world, dear Rohan. Yes. And there are lots of questions. Yes, I will be sending the copy of the presentation to dear Mokshita, and so she can share the presentation with you. And what is the difference between industrial Internet of Things and Internet of Things? I understand now, Divya. Thank you for making that your question clear. Industrial Internet of Things, I actually have a special issue running currently for even industrial Internet of Things, but when you write IIoT, I couldn't get that at first, sorry for that. Industrial and Internet of Things means, as you can see from the word of industrial, you just make use of IoT in industrial environments, which means factories, which means environments with constructions, maybe with bigger trucks or devices to make something constructing, or something in terms of manufacturing or using the factory-based components. That's the Internet of Things in terms of industrial manner. What is different between IoT and AI? AI is another component for IoT. I can say it like that, dear Sam. IoT is the technology, another technology form for a communication technology, which means physical communication of devices. But AI is the smart use of algorithms for better solutions for real-world problems. Yes. And there were two final questions. So IoT can be considered as a parental thing? Yes, dear Part. You can think like that as a parental thing of wireless sensors, as wireless sensors may depend on IoT. Yes, we can think like that. Dear Vuyomesh asked that, can you give an example of smart tool currently being used for disease analysis? For example, you can think about deep learning components using some analytical or some disease analyze tools to early diagnosis of breast cancer, for example, by using some medical image, CT or X-ray or other things to predict the disease regarding cancer, or maybe, for example, some tumors in the brain, maybe there are such things, and by just taking that component to the real component, real device of diagnosis system, you just get a smart tool. For example, you just use some smartwatch to sense your heart rate, for example, and other things like sensing everything from your skin, of course. That smartwatch just use some sensors over that, and just by using that, it can be just used for disease analysis in further terms. Of course, some disease may be needing some more additional data, but by just using even some sensors over smartwatches, you may just reach to disease analysis, of course. Yes. How is Amazon Web Service implementing IoT? Dear Sashank, Amazon Web Services have some services regarding IoT. You can just search over the web as writing Amazon Web Services and IoT, and you may just reach to many different services by just using the API and the cloud system to make your systems to be running. Okay. Dear Rohan asks us, computer vision or ML or AI? Computer vision, actually, the way of the defining that your system just understand about the real world by just using camera or other sensors, and on the background you may be using image processing, machine learning, and other maybe optimization algorithms, which means machine learning and AI are just components for ensuring the computer vision. So I can say that yes, computer vision, but on the background, you may be thinking about which types of components to be working on, machine learning or image processing. All of these components are just gathered to ensure computer vision solutions. Yes. I think the questions are yes. AI and IoT is also broad, as dear Mayur also indicates. Yes, certainly, dear Mayur. Yes. And if you have any additional questions, let me to just write again my email ID, dear friends, because I don't know if there will be, of course, there will be other sessions, so I will not be taking your valuable time. Of course, you may be also visiting my website, as I said before, to be understood better about my research, of course. There is my institutional mail address, as you see, but you can send mail to my Gmail account, of course. Okay. AI and IoT penetration in manufacturing industry, we should be analyzing that, I think, yes. In manufacturing, there are many research works, dear Etish, but in terms of giving exact numbers or rates, we should be researching or searching for some papers regarding that. But I know that with the start of the 21st century, all fields of industry are started to be affected by AI, automation, and IoT. You can just think like that. With source coding using in AI, source coding, you mean programming language? I suggest Python for faster solutions, but you may also just thinking about Java or C-oriented programming languages, but just think about writing some manual codes at first, not using libraries to understand better about details of the algorithms. I always suggest that to all of my students and also during my webinars. So I just suggest that all of you, dear friends, yes. Yes, dear Aja, say that the agricultural sector has huge potential, but need cater to the need of the people, of course. Yeah, it's always important for everywhere. Yes, certainly. Yes. Thank you very much, dear friends. One of our friends says that for Python, I think which IDE is best. I use Spider. It seems better, but everybody thinks about using PyCharm. You may also be using that, but I suggest Spider. I just suggest, and I just suggest installing Anaconda to reach all of different components for writing Python by using Spider, by using other Orange, Jupyter, other things. Yeah. Yes, how about Oracle IDE? I didn't use that, so maybe after using I can answer that better, dear Abel, because it may be false to derive some ideas about that without using that. But I can suggest Spider. I better comfortably using Spider rather than the PyCharm, for example. I mean. Yes. Thank you very much, dear Professor. Professor Shihana, thanks for your positive feedback. Thanks everybody, every friend, students, and my colleagues from different regions of India and also different countries over the world for taking place in that such valuable webinar session. Yes. Thanks, dear Mahatre, Dr. Mahatre, for your contribution. As I've said, if you have any questions, just do not hesitate to contact me via mail. Yes. So I would like to take your more time. I think we will be just finishing the session after the presentation. I'm from Turkey, dear Sam, from Turkey. You are always all welcome to visit Turkey, of course. Yes. Dear Neha, yes, I may give the speech to you. Some of friends are asking about the certificates. You may, well, of course, you may be answering them. So thank you very much for your great invitation, kind invitation for realizing that webinar. So thank you, everybody. Thank you. Yes.
Thank you, sir. Thank you for sharing such valuable information and handling all the queries so patiently. We are very grateful for your time. Thank you for enlightening us on IoT solutions in COVID-19 very briefly with related contents as well. Thank you for accepting our invitation and making this session wonderful. It was very informative session and I hope all the participants are benefited by it. Participants, we will be sharing the PPT with you on your registered email IDs. Thank you once again, sir. I would
Thank
now
you very much.
my colleague, Ms. Kajal Singh, to proceed for the next session.
Yes, thank you very much. Thank you. I wish all best for your future events, of course, and thank you very much for everybody, every friends from around the world for your valuable taking place in our event. So wish to have more collaborations in the future. Have a nice day. Thank you. Thank you very much. Thank you.
Thank you, sir, and thank you, Neha ma'am. I, Ms. Kajal Singh, would like to take this opportunity to introduce you all to our next eminent speaker, Dr. Hani Kyusa. Dr. Hani Kyusa is a dedicated information security professional with a strong academic background, teaching and research experience. So, has completed his PhD in computer engineering in the year 2000 from the University of Rome, La Sapienza, Italy. Currently, he is an assistant professor in the Department of Computer and Information Systems in Higher Colleges of Technology, Dubai. Equipped with excellent scientific and technical skills, good observational skills, well developed analytical and conceptual thinking skills to problem solving using IT solutions, he participated in several EU funded Erasmus Plus and ENPI projects, including BitPal, STEP, Diadalis, and MidMobile. Dr. Hani's research interests include security intelligence, privacy preservation in collaborative environments, secure multi-party computation protocols, distributed computing, and secure distributed systems. Sir, it is an honor to have you with us. Dr. Hani to enlighten us on the topic Big Data Analytics for Collaborative Defense. Over to you, sir.
Thank you, Gajal. Just I would like to check if you can hear me well, or I have to put the headphone. Can you hear me? It's good. You can hear me.
Yes, sir.
Okay. Thank you, Kajal, and good afternoon, everyone. I hope you have the energy to another 1 hour, because really it was a very interesting presentation, the previous one with AI and after COVID-19. So thank you very much for this invitation. It's my pleasure to be with you. Now I would like to share presentation windows. I think select this one. Okay. Share the screen. Then can you see the presentation now? Can you see now the presentation?
Yes, sir.
Okay. Good. In this webinar, there's a little bit change in the title, which is Big Data Analytics for Collaborative Defense. In fact, as in the previous presentation, we are mixing some big topics in order to provide system requirements and satisfaction for system requirements for several sectors of AI. We know very well that the future is for automation, and this automation cannot be continued without securing this infrastructure for them, securing endpoints, and so on. The collaborative defense as a concept, it's a new, let's say, but a lot of research is highlighted in this because collaboration defense is something, let's say, new and not well studied. Let's say it's an amateur experience that needs more investigation in order to build this collaborative defense. In this presentation, I will do my best to clarify where is big data analytics and where is the collaborative defense, and how we can use this in to provide all the security requirements for the end user. For the presentation, we will start by introduction to big data. I am not going to into too much details in everything. It's just an introduction. We will talk about information security dilemma. What is the future of information security? After that, we will talk about, in part 3, introduction to collaborative security.
So I'm sorry to interrupt. The audio is slightly low. It is audible, but it is slightly low.
Okay, it's better to get this because maybe, yes, I know there's a problem with my mic here.
Okay, now I think it's better.
Yes, sir.
Okay, starting by introduction to big data. You know, we can think about big data by thinking the history of the data. In the 90s, we started thinking about big data as a simple relational database in which we store data with records and we just extract data using reports. This up with interaction business and intelligence in memory relational database management system in 2000s, start 2000s. Then scaling up of the data was necessary to use another infrastructure rather than simple relational database management system. So we start introducing the concept of distributed file system, distributed databases, in order to start and using with the concept of Hadoop, Spark, and using the concept of NoSQL. Now the need is in 2000. Yes.
So I'm so sorry to disturb you once again. Sir,
yes.
Is the PPT started, the presentation? Because we can see the Google Meet ka screen.
Okay. Now, if I start this, can you see the slides, or it's better to go in this way?
So we can still see the Google Meet screen.
Google, okay. Let me stop presenting.
Sure, sir.
Then present now window. In the window here, share, you can see now the presentation.
Yes, sir. Now it's visible.
Okay. If
So
I
have the mic slightly near so that we could hear it more clearly.
You want, okay, in this case, is it good?
It is true. So can you please repeat once?
Okay, okay. Here we talk about the evolution of business intelligence, okay? In this presentation, in this slide, from 19s. How was it? It was only a simple database with the tables, with the records, okay, in order to extract simple reports. In 2000, the beginning of 2000, there is an interactive business intelligence in memory relation database management system that was scaled up again to a big data we need in order for batch processing using Hadoop, Spark. Now, at the end, what we need big data, real time, and single view for using graph database. This evolution comes from the fact that we have a big data to manipulate, to process. What's the meaning of big data? In the previous presentation, I heard one question about simulation of a human brain. In fact, in this slide, there is an experiment of one big university, or IST university in Japan, that use K computer, which is one of the fastest computer in the world, okay, with 82,000, more than 82,000 processor, in order to mimic just a synapses network of a human body. The process, in fact, took 40 minutes to complete 1 minute simulation of our neural network activity, which represent 1% only of our neural network in the brain. This returns to the fact that all of our thinking is different. I'm thinking in different way to solve the problem. You are thinking in different way to solve the problem. What we try to build is an AI simulation to mix between my idea, your idea, in order to build a solution and pre-configure this machine with this solution. So it's very hard to think about a machine thinking like a human. We can reprogram for a small specific task, but in general, it's very difficult. And this is an experiment that we are talking about huge amount of processing and storage in order to mimic only 1% and 1 minute of human brain activities. This put us in a real challenge. What's the meaning of big data? If we are going in the future to depend more on AI technology, this means that AI needs more data, more storage, more velocity, more processing, and everything. There are several definitions of big data. We will let's say concentrate on the concept, on the characteristic of big data more than the concept itself, the definition of this. Some of the definition is data whole, scale, diversity, complexity, require new architecture techniques and algorithm. This is one definition. There are other definitions. You can all look from Wikipedia by this and think about the other alternatives of big data from several resources. Is a challenge include capture, curation, storage, search, sharing, transfer, analyzing, and visualizing data. Is it the future? Yes. Dealing with big data, dealing with the storage of big data, dealing with the processing of big data, dealing with a networking of big data is a good topic that you can invest in the future. This is just a graph that shows us let's say the investment in big data market forecast. In the future, this market will never go back. This market will go increasing year by year. And we can imagine that building a new way or a new, let's say, tools for providing and simplifying big data analytics is a good investment in the future. So the idea from where this data comes, the old model, there is a companies, there is newspaper, there is a news letters, there is some systems that we extract data and give this data feedback to the people. Now the new model is people give data to people. So we are extracting data from people in order to process it, in order to provide them another feedback of data. This model, we can see here from where we can generate this big data: mobile systems, scientific infrastructure, social media and network, sensor technology and networking, several sources of big data that can be used in order to provide another solutions for automation. Why big data we need? As I explained, there is a high volume, there is a high variety, there is a high velocity. All of these in order to provide more automation, more AI intelligent system that can provide real services for people. No one can deny this fact that automation is the future. But what we need from automation is not a new machine instead of people. We need an intelligent machine that can decide, make a decision. And we have seen that this decision cannot come from a simple set of data. We need big data in order to analyze this. We can see that if we want to understand what's the meaning of big data, just we can have a look on the internet life status. Okay, just if you open this website, you can see number of traffic that generated by day or by minute or by several things. Okay. The second thing is the variety. Variety means several types and the structure of the data that can be generated from several sources. This makes it difficult to make, let's say, a structured database or store it using a structured database. So what we need is different type of data that can store several types of data like text, numerical, image, audio, video, sequence, and use statistical data versus stream data. Single application can generate a lot of data. Also, from security point of view, we are investigating in several, let's say, appliances that generate data, different format. What we want to do is to, let's say, investigate this different format in order to reach to one common format in order to understand the vulnerabilities and risk we face. Okay, this is just an example of customer from where you can extract data, how much is different type and variety type of data that we can collect from different data. The velocity, yes, it's important that we need real time. We are talking about real time all the time, real time interaction, real time detection of intrusion, real time of reaction to new risk and vulnerabilities. So, for example, in the healthcare monitoring, we need the sensor to react, to collect all the information, and to give a notification for exact people to react to the system. Some of definitions make these 3 V's to 4 V's, adding veracity, which means that there is now a huge amount of data. There is a high uncertainty of the source of the data. So classifying data to fake data, real data is another challenge that face big data, let's say, field. Examples of big data, several examples we can see from big data exploration, big data 360. One biggest example we can see in the social media. Each one of these social media represent a real challenge, represent a real example of big data manipulation. We can see how many tweets, we can see how many posts in Facebook, how many images uploaded in YouTube, how many videos uploaded. If we think about this data and the reaction when you click, for example, like or retweet or something, and this reflected to the original user or the author of the post, or this reaction needs a huge big data infrastructure to manipulate this data in real time. So now if we are talking about what's the difference, someone will ask, okay, what's the difference? Why we don't simply use real database, relational database management system, and what's the difference between this and big data? We can talk about big data and business model. In relational database management system, there is a collection of data, there is a usage and decision impact, which is very close to the end of the collection of data. While big data, we are taking this data, we are analyzing it, we are foresight the future, okay, of this data. So we are not collecting data to make a decision right now for a problem right now. No, we are trying to make a decision for the future, to solve and to facilitate and solve problems that we may face in the soon future. If we are talking about now technical level, we can see here some technical tools that we can use for big data. Now, big data is not a simple relational database management system. We cannot use a simple SQL. We try to mimic this easy way of using an installation by simple other infrastructure. What we have, let's say, a new system that talk about distributed database, distributed file system, implemented using Hadoop. Then we have processing of the data, several solutions for processing the data. Then we try to, after storing this data and processing it, we try to extract data using a query language or semi-query language. So we have set of query languages in order to help extracting important data from this processing of the data. For streaming, we have other solution. Now, someone will say, okay, how can I go ahead? It depends on your application, depends on your system requirements. If you think about when in our, let's say, scenario, we are talking about collaborative intrusion detection system that we are going to discuss as a case in our scenario. For example, our selection for storing the data, we need Hadoop distributed file system. For big data processing, we can use MapReduce. For big data querying, we can use Hive, developed by Facebook data infrastructure. For machine learning and improving our detection system, we can use Mahout on Hadoop the system. If you think about this, okay, now you can think about solution, any solution, and you can select your series of these technologies in order to fit for your application or for your system requirements. Of course, any new combination for this solution will make a difference in performance, which is very important. Now we are talking about the speed, velocity, okay, let's say the throughput of the system. So making a good selection is important, which depends mainly on the system requirements. Now we can say that we concluded the big data, let's say, introduction. After this, there is a big data, some challenges that we have to address during any design of big data system: big data security and privacy. This is important because we are talking about distributed machines working together, having all the necessary access to all of these resources in order to do all necessary processing for the data, stored data, redundancy of this data, and so on. Data sharing and exchange, data storage, memory storage, how we can distribute data in a way to ensure availability, integrity, and everything. Human consumption of the result of big data, visualization of the big data issue, interface between relational and non-relational query languages, big data quality, and veracity is very important issue, which requires more investigation, in fact, which is how we can differentiate fake data from real data. This is, in fact, a big topic for research and for development. In the second part, we start talking about information security dilemma. the current situation. From Cisco foresight, they expected that cybercrime will create over 1.5 trillion per year in profit. What do we mean by in profit? This is a revenue that is made by, let's say, the malicious attacks, okay? The malicious attacks is a winner here in this case, but this is are considered as a losses for several industrial sector, governmental sector, private sector, several sectors. We can imagine that how much currently in 2020 the real losses is estimated to be 2 trillion US dollar in several sectors. If we look to just to understand from where these losses can be, let's say, analyzed, we will discover that there is malware, there is fake fraud, there is several, let's say, attacks, sophisticated attacks. In order to prepare for this, no one can deny that in COVID-19 now there is an increase in these attacks by 33, according to some resources, by 33%. Yes, this returns to the high number of job lost, which means, which open the space for this let's say cybercrime to increase, because okay, there is a job cut, there is unemployed people, there is an easy way to gain money. Yes, it's not easy, but it's, let's say, it's possible. The problem here is we think that we are ready technically for, and we can solve our security, information security technical issues easily. In fact, our problem is not in technical. According to Cisco, 75 of the attacks can be solved by non-technical solutions, the awareness. So most of the frauds happens because of the spam, because we follow some emails that fraud us and put us in a trap, let's say, to follow them, to give them some information, okay, intentionally with our acceptance. This give us the, let's say, a possibility to improve our security by non-technical solutions. So if we think about that, we need only 25% of technical solution to secure our environment, and we need 75% to secure our environment and system by just an awareness, by just putting real and implementing policies that govern, that let's say govern and control bad behavior, good behavior, guide people what to do, what to not to do. Okay, this is important in the current situation. What do we face? Okay, all of these are just an examples of malware attack, and all of these also an examples of some technical solutions that we need. So someone will say, okay, according to this estimation, okay, and the increase of the security risk in the world and the new situation after COVID-19, so we are going some expectation that talk about we need at least 1.5 million skilled security professionals by 2020. Now this is increased to 2 million position, new position only for skilled security professional to provide security, information security, just only for 25. Yes, and the rest can be designed by policies, suitable policies, by awareness, which is a new skills that must be get by higher management levels. This, of course, put us in a way of thinking of the security. What is the information security? How was it is, and what is the evolution of this? If we talk about information security, at the beginning, we say, okay, let's think about, we are talking about we are in non-secure state and we want to go to secure state in our system. We are not, for example, we are in non-secure state because everyone have an access to our database system. So our confidentiality, our integrity, our availability are at risk. Okay, so what we need to do is to provide technical solutions in order to move to secure state. By providing these technical solutions, what we satisfy confidentiality, integrity, availability. This is the traditional way, okay? And what we call is a basic way or a proficient way in which we provide reactive and manual solution for our security problem. So what does it mean? There is a risk, there is an incident. We try to react to this incident. The new thinking and evolution of information security is the optimized one, which is security intelligence. We are going to talk about a new system that provide automated and proactive solutions that think instead of us. Now we are talking about some AI solution. We are talking about security intelligence. We are talking in some machines, some systems that take in advance some steps to warn us, okay, alert us about some risks that we can face if we continue doing things in the same way. So this security intelligence, let's say, is the hot topic in security, and now it's well investigated in the field of information security. So security intelligence is a way of real time. Now we are mixing what we need from big data. We need a big data system that manage to collect, process, analyze severe a huge amount of data in real time and give us some let's say recommendation to make a new decision. So security intelligence represent a big data system for us with AI solution to think instead of us, okay, and warn us from some possible risk in the future. Security intelligence is something that we need because we think that this system will aid us, not will work instead of us. It's not possible to let the system work instead of you because of some suspicious data. At the end, this system will define exactly what's the meaning of suspicious data and give us at the end the help to make a good decision, either to continue or to not continue in our system. Some top solutions that now provide, we can see here from some resources. It's called Security Information and Event Management System. There is big companies providing this, from IBM to McAfee to other systems that can really talk about security intelligence. Right now, we are far from the concept of we are not far from the concept of collaborative security. In the collaborative security, these systems are talking about one organization point of view, one organization's security, where the organizations try to protect its infrastructure and endpoint users and endpoint systems. When we talk about endpoint system, we are talking about PCs, laptop, mobiles, and so on. All the new, let's say, concept and terminology of the new organizations talking about, okay, this is an endpoint security or infrastructure security. So doing this alone will provide you by some level of security. But in fact, what we face is a sophisticated, as I mentioned, a sophisticated attacks. Sophisticated attacks come from a range of, let's say, a collaboration in attack. It's a collaboration. So what a sophisticated attack is, a collaboration between attackers that must be faced by collaboration in defense. So in the third part, I will give just introduction about collaborative intrusion detection system. In fact, what we are doing now, we are trying to put a system that try to detect any intrusion or any expected risk that could happen in the future and inform us to either by recommending some action for us or give us the possibilities and the risk vulnerabilities, explaining for us all of these details in order to allow us make the decision. So the best way to say that I want to collaborate, one organization want to collaborate with another organization, usually this can be done using from the same player in the same sector. For example, set of banks try to protect themselves from fraud attack. Set of, let's say, supermarkets try to protect themselves. Set of ministries try to protect. There is, let's say, a collaborative. The collaborative defense means that set of organizations try to protect themselves from from several sophisticated attack. Now, each organization try to protect and to investigate and to monitor the network by itself. Okay, and if there is some suspicious activities, they try to exchange this information with others, saying, okay, this is important information. I would like to check if this is also represent for you blacklist or suspicious activities. Please inform us, help us. So these systems that work individually in each organization is intrusion detection system mainly. So what we want to do is a network between intrusion detection system. So intrusion means first of all a set of actions aimed to compromise security goals, integrity. So there is the intrusion is an attack that want to put the organization and move it from secure state to non-secure state. Okay, this is why. This is because we want to move to affect integrity or confidentiality, availability, or currently utility, privacy, accountability, several other security properties. By affecting them, we move the organization from non-secure, from secure state to non-secure state. So in order to do that, we need intrusion detection. Intrusion detection is the process of identifying and responding to intrusion activities. So there is an attack, and this attack we are trying to do our best to stop them, this attack in advance. There is intrusion prevention. Intrusion prevention is if we know the attacks, we can prevent them. One biggest example of intrusion prevention is firewalls. Firewall is intrusion prevention because we know that this IP is bad IP, or let's say consider a threat for us. So we stop this, the communication and the traffic coming from this IP because we know this. We can say this is intrusion detection, intrusion prevention system. But in case we use always the idea of intrusion detection. Why? Because we suspect, okay, we feel that this is suspicious activity and we need to investigate this. So detection is an idea of checking uncertainty of the events. So what we need is more intrusion detection than intrusion prevention. It's good. We need intrusion prevention. But if we know, but the uncertainty is high in security, nothing is certain. We can't say that we are secure 100%. It's impossible. Okay? And if we say that, we should notice that there is a decrease in the security and there is a loss of jobs in security, information security sector. However, what we see is an increasing number of attacks. Why? Because there is a new way of attacks. There is a vulnerabilities in several protocols that right now has not been updated. Okay, but we need these systems. Why? Because it depends on the automation again, because we need the automation of these systems. So this is important to differentiate between intrusion detection and intrusion prevention. We need a collaboration between intrusion detection. Why? Because we want to share our suspicious activity. If we know the things, we prevent it by ourselves. And we just inform the other, look, there is an attack, stop it from your side. Okay? Because we have certainty that this is an attack. But the real world show us that there is high uncertainty in our decision, especially in the security issue. Sometimes the traffic is malicious and we consider it as benign. And sometimes the traffic is benign and we consider it as malicious traffic. So the need for collaboration in intrusion detection is very high, but it's limited right now. So now what we have in element of intrusion detection, we concentrate, as I mentioned, we will concentrate more on element of intrusion detections. Primary assumption, system activities are observable. We need to ensure that all of activities happen in our network are monitored. Okay, normal and intrusive activities have distinct evidence. We can prove that there is an attack by set of evidence through investigation of these automated and recorded events. Component of intrusion detection system, we need algorithms that help us to build future features and get, let's say, evidence, and model that try to classify, categorize, decide, help us decide what are the good and not good traffic. From system architecture, of course, if we are talking about monitoring the traffic of one organization, we are talking about organization. Let's talk about one university. In one university, there is, for example, 2,000 PC with several services running in the same time, using internet in the working hour. And we can think about, if we want to monitor each packet coming in or coming out through network and make a good investigation to decide this packet is good or not, bad, we will cause a slowdown in the internet usage and in the network. We will create a heavy traffic and buffering system suffering from several packets that waiting for investigation. So what we need is a good system architecture that can help minimize this processing time for intrusion detection as much as possible. So what we need is an audited record, and this audited record, we can think about list of preconditions that we put as a detection model. This detection model help us to preliminary classifying the traffic between suspicious, non-suspicious traffic. Then we have decision table that help us to decide this engine, okay, this is good traffic and go ahead. No, this is suspicious traffic that it moves from simple event, okay, it's an event. No, now it's not an event, it's an incident. And we have to report this and take the necessary action in this for this incident. So if we talk about the intrusion detection approach, how it works, okay? The feature, how we can extract and decide the features of intrusion detection. We are talking about misuse detection, anomaly detection. In the case of the, let's say concentrate on this, because the deployment now, we have network-based that monitor network, or host-based endpoint security. All of these, why? To build a one intrusion detection system for organization. Then what we want to share this information with other organizations that to build collaborative intrusion detection system. So by looking more in the misuse detection, one type of detection which is known as signature based, this works as antivirus. There is a signature for already known malicious activities. In this, we put this in, let's say, a database, and using several searching AI searching mechanism, we build our pattern. In the pattern, we decide that according to this pattern, this is already shown in our database according to a specific signature of this attack. So this is one example. If traffic contains blah, 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 then attack detected it, we can stop it. This can be considered as intrusion prevention system. However, here, what we put is a machine learning, and there are several protocols that are talking about improving these intrusion patterns, okay, by several conditions in order to apply for the new traffic to check if there are malicious traffic or not. So these conditions, okay, is built using machine learning process, okay. Machine learning process did put us that, okay, we have some preconditions, but this preconditions is improved using machine learning process. So this misuse is, let's say, working as normal intrusion detection system. And what we need, in fact, is another way, more developed way to think in advance. This is, let's say, more reactive, and we need more proactive mechanism. So anomaly detection is the best solution we can use for intrusion detection system. In the anomaly detection, we just specify exactly the meaning of good behavior. So for example, the good behavior is to open Google, your social network, and so on. If you open this IP address, anything which is not specified as good behavior, it will become suspicious behavior. Suspicious behavior means that I am going to give you more details about investigation. So define profile. This anomaly detection means that there is a definition of a specific profile describing normal behavior, then detect a deviation if there is any problem. Relatively high false. Why? Because what we can say is a good behavior is 1, 2, 3, 4, 5, 6 to 10. Okay. If there is any new bucket out of this 10, it's a suspicious behavior. Then it goes for more investigation. Of course, what we do is investigate. We found that this is not a real attack, or this is not malicious behavior. So we go for what? For false positive rate. This means that there is a good traffic, but we consider it as a suspicious attack. Okay. So in this case, there is, let's say, too much alarm rate, saying there is a problem, there is a problem, there is a problem. Okay, which we call it intrusion detection system sensitivity. Okay, anomalies caused by other elements faults, for example, router failure or misconfiguration. How this data is generated. Okay, all of this data can be generated from different devices, as we can see, and this investigation is done on the data generated by these devices. Sometimes these devices are just because of electricity outage. Okay, shut down. So it generates that there is no signal from a specific device. This is an alarm. Okay, it's out of the normal behavior. So we discovered that there is only an out of security electricity current. About the infrastructure, we have two things: host-based IDS, which works like, let's say, antivirus, anti-spamware, anti-malware, anti-phishing, anti-virus, several things. We call it host-based intrusion detection system that monitor all the traffic, trying to understand what is good, what is benign, and what is malicious behavior, monitor shell and other system call executed by user, application, and system programs. Problem in this, user dependent. Okay, there is if the user, for example, decided to remove the intrusion detection system, it cannot participate in the collaborative defense. So, for example, where is the collaboration here? I put my host-based IDS. My colleagues install host-based IDS. At the end, we have a network of host-based IDS that exchange the network between them, the alerts and suspicious traffic between them. However, if I want to decide to shut down my IDS, I can exit from this and I can hide some important information that can suffer from the others. So the collaboration here is limited in the host base. There is a problem of install, update IDS for all user machine. We face a real problem. We cannot guarantee that collaboration between single intrusion detection system can continue, because someone decided to stop functioning of as IDS and he or she is under attack, and we cannot recognize this in time. If the attacker take over machine, can tamper with ID binaries. So in case if we are depending only on the host-based IDS, in this case there is the attacker, the possibility of attacker taking the control of one machine because of some undetected virus or malware. In this case, he can understand, or she, the attacker, can understand part of the network infrastructure, part of the malicious behavior exchange between intrusion detection systems. In this case, he or she, the attacker, okay, can understand how to manage a new attack on this network. So here is the problem of host-based IDS. The idea is to use network-based IDS where we monitor all the network traffic coming to all the host base. Okay, this can be done using big infrastructure that depends on big data. This is why we need now big data, because we are monitoring and providing intrusion detection system not for single machine, but for a network of machines. Okay, in this case, we are monitoring all the traffic. We need to the infrastructure to store this traffic and to process it in time and give notification for principals as fast as possible. At the early stage of worm, only limited worm sample. Host-based sensor can only cover limited IP addresses, while network can cover a huge part of, let's say, IP addresses. So deploying sensors at strategic locations, for example, what's the meaning of sensors? It's a network inside our organization. We install a set of host-based intrusion detection system, network-based intrusion detection system, and communicate all of these data and store them in one place for processing. This deployment can be done also by other solutions like bucket sniffing solutions. Then inspecting network traffic, watch the violation of the protocol, look for into the bucket payload for malicious code. Several solution was provided to do this from Cisco. Juniper Network is one example just for this. We can think about CM system, security information and event management system, that was that I talked about in the security intelligence, as one of the best network intrusion detection system inside one organization. However, what we need is an exchange of this data between several organizations. However, this network intrusion detection also suffer from limitation, cannot execute the payload or do any code analysis. Even deep packet inspection gives limited application level semantic information, records and process huge amount of traffic. Yes. Okay. So what do we what we should monitor in order to do what metrics we are going to investigate? First of all, we are going to talk about algorithms. We are going to implement our alarms, when to launch a specific alarm. We are talking about detection system, how to improve the detection to minimize false positive and true negative, let's say, signals. We need to think about architecture through how to design a network of intrusion detection system targeting tens of gigabit per second that can solve several problems and exchange important and malicious data between this network. Then we are talking about how to protect this network itself, how to make it immune against attack. So this is the architecture in one single point in network intrusion detection system: packet streaming, packet capture, TCP reassembly, protocol identification, signature matching, and anomaly detection in one point. Then we think about this scenario in which we have one intrusion detection system, several intrusion detection system. In each intrusion detection system, we have these deep packet inspections, and we have a system to inform the other about these attacks that I suffer from. Collaboration here means exchanging of malicious traffic, exchanging of blacklist, exchanging of possible attacks and vulnerabilities, threats that can happen for one organization and could be an interest of the other organization because they are working in the same level. This is one collaboration between, for example, bank system that suffer from a fraud attack or trying to get information about the customers of one bank. Okay, how we can know this information about the attacker, how we can exchange this information without revealing customer data to other intrusion detection system. Here is some limitation of collaboration in this field because some exchange of some important data is considered illegal because you exchange some information about your customers. So there is a limitation for collaboration. And here one big challenge, which is in collaborative intrusion detection system, privacy. How each organization can protect itself from a privacy point view. This is, for example, one single architecture that you can do in to help organization to exchange data using necessary obfuscation techniques to obfuscate, let's say, some customers' data, and the infrastructure for each participant or intrusion detection system is done using Hadoop system, Hive, and the required system architecture. So this is just an architecture, that possible architecture. You can imagine that this network, this cloud can be designed in mesh technology and ring technology, in any way to exchange the data between these organizations in private way. So the problem with current intrusion detection system in accuracy, yes, right now there is a big investigation to improve the accuracy of intrusion detection system. There is a high rate of false positive, which means that there is no attack, but the system gives us alarm that there is attack. There is high possibility to not recognize anomalies and intrusion, which is true negative accuracy, which means that there is an attack, but the system cannot discover this right now. Several systems suffer from this. Cannot provide equality for the forensic of situational awareness analysis. Hard to differentiate malicious event with unintentional anomalies. Cannot tell the situational aware info, attack scope, target strategy used by the attacker, who is the attacker. So a huge, let's say, investigation and research is done for collaborative intrusion detection system, which is right now going on. Participation on this currently in HCT, we try to develop, let's say, our collaborative intrusion detection system using existing infrastructure. For example, as a university, the working labs, PCs in the labs are used for half a day, okay? The rest of the day, they are in idle state. Can we reuse this big infrastructure in the network, for example, of the university? Can we reuse it again for several purposes, for example, for making collaborative intrusion detection system? So what we do here, in fact, in our research, we do investigation to build collaborative intrusion detection system by reusing the existing infrastructure. We don't want to buy new servers for intrusion, to buy new PCs, to hire a new labs or cloud infrastructure from several providers. No. We want to reuse the existing infrastructure to build this big data system to provide not only security services, but other services. For example, if we are talking about the huge amount of the infrastructure that we have in universities, for example, we are talking about huge amount of data, free spaces that can be used to provide backup system, that can be used to provide free space cloud to be sold. In our investigation, the first step is to provide the security collaborative intrusion detection system using the existing infrastructure. So we have several issues that we face right now, which is privacy, how to secure the data against working day user. For example, the user using the PC in the lab, but there is important data stored in the lab. Can we do this in a secure way, store this data in a secure way in the lab, and so on. So we think that creating such a system that can reuse the existing infrastructure and making it customizable, let's say, to any organization, will provide several solutions for any organization to, let's say, to minimize the cost for security, the cost for backup, the cost for free spaces needed. Then the next generation of IDS, vulnerability-based, adaptive, we have automatically detect and generate signature from zero-day attack. This is important. We need to correlate as much as possible. I hope I was clear in my presentation. Thank you very much for your listening and paying attention. Okay, I see some maybe questions. Okay, there are two. Okay, presentation is visible and sound is clear. Thank you. Okay. Okay. Okay, okay. Free bases. Okay, now there, for example, one big system that you can use for big data, Spark is one good solution that is considered free. There are also some solution, but it's limited edition from Cloudera that you can use to build your big data solutions. These are some solution. Yes, R is a good language and a good tool to analyze your data, but currently there are, instead of using R, everything is built over Java currently. Several packages, API, are provided by several tools. So you can use R, you can use Python, you can use Java to improve your analysis tool. Okay. Okay, okay. 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 Can we make a use of proxy servers for intrusion? Yes, you can. Building your own network inside your organization is not a big challenge because you have several resources that can provide you with data. What you need is to design your infrastructure to not affect the traffic mainly, and to collect as much as possible data. Okay, as mentioned earlier. Okay, I'm sorry if there is the problem in the presentation. Some of you didn't was not able to see the link. We are provide there. Okay. Okay. You cannot see now the presentation. Okay.
Sir, we can see the presentation.
Okay. Okay. Now, as I mentioned, Java is one of the preferred big data languages that can be used. It's most popular. Most of the tools are implemented using Java, and most of the libraries are built on Java, but you can use Python. Python is, let's say, compatible, most compatible. Several Java APIs provide for Python also languages. Okay, most of them is about problems in. Okay. Zero question join session. Provide. Okay. How to find attack? Yes, it's not an easy question to answer. If it's easy, believe me, we finish the story of information security and we have a completely secure attack, secure systems. But this is return to the standards. We know that all of applications run over protocols, using protocols. Most of these protocols are designed to provide functionality, okay? In order to provide this functionality, they have to compromise some security issue. These are the vulnerabilities. So providing good protocols and improving good protocols, okay, in the network will simply solve partially the problem. But again, most of the problems come from non-technical issues. For example, when you have some fraud emails or phishing examples, you can penetrate, let's say, simple user access and behave as this user as in the system. So it's not easy how to find the attacker, but what we do is we do our best, we do collaboration, we do intrusion detection system in order to find this attacker. By default, big data systems provide redundancy as minimum security level to have recovery servers. So the data is redundant in big data. So why we need big data systems that run over network of PCs, for example? Because if we store the data in one PC, okay, there is a redundancy of this data in another PC. So if there is a shutdown in one PC, the second PC will run automatically. This is the recovery system of big data. How does IDS works on outlier, Rohan? Rohan, maybe I don't get the point of outlier. If you can, Rohan, if you can just clarify what's the meaning of outlier. Thank you. Thank you all. Yes, you can, as I mentioned, you can set your proxy server as intrusion detection system. The idea is which application you are going to install. Which language is preferred for big data? As I mentioned, it's Java mainly, but you can use also R, Python, and so on. Thank you all. Which language is preferred on data? I'm reading fast. Maybe I missed someone vulnerable. Valuable information. Thank you. Okay. Okay.
So do you want me to read the queries?
No, I am now all the record in this. Atish, measure which take when any cyber attack happens, but how data analysis can help us to build any model to predict proactively and future cyber attack as prevention. Okay, this talks about you are talking about more anomaly detection. Anomaly detection, in anomaly detection we define the good behavior. What else is considered as malicious behavior, and we start making all necessary investigation. So in case of predict proactively means that if we define good behavior, the system can start analyzing bad behavior according to some pre-exist list of conditions. So we can say to start with, or we can say to practice on big data. Hadoop, I think if you start by Hadoop, using Hadoop to install it on different machines to build your distributed file system. After building your distributed file system, defining the name node, the data nodes, and the all infrastructure, you can then build your let's say the way how to store data. You can use Hive, you can use Big in order to specify how you are going to store data. Then you can start collecting data, normalizing data according to some common form. Then you use Hive as a tool to extract this information. As I mentioned, these are all free tools, okay? You can use some other tools from Cloudera, okay? Some of them are free that you can practice on them. Complex servers for intrusion detection. I think it depends on where do you, what is the function of the proxy in this case, okay? The main function of the proxy, what is it? Language of preferred, okay, Java, as I mentioned, is necessary to create disaster. Yes, I already talked about this, which is about that big data system already designed to have a redundant system database. Okay, so you can use the same storage redundancy, okay, to build your own recovery system. So go with ID process. Yes, this is necessary because this means that you build an immune intrusion detection system. So this means that you build your own intrusion detection system, protecting your intrusion detection system. What is preferred working on good data or good model? It depends on intrusion detection system. There are, for example, some already existing open, for example, Sumo, okay, is one existing CM intrusion detection system that can be used. Snort can be used as intrusion detection system. D-Shield is used as intrusion detection system, collaborative intrusion detection system. There is difference solutions that is either centralized or decentralized model, okay? Okay, I don't know what do you mean Mitesh by DAG model. If you can clarify this. Okay, how does ideas? Okay, Rohin, just if you can clarify the outliers. So it's difficult to find sure such attack, but I feel as. Oh, yes, this is important. This field of study is currently known as security intelligence. If you concentrate on the concept and start looking for this, you will find several solutions that provide, but it's still immature, as I mentioned. One of the biggest is Splunk. Splunk provide one good CM system. QRadar is another one good system. Logarithm is another good CM system. All of them provide what you mentioned is proactive security. Okay, okay. Okay, I don't get your point, Manali. What I prefer by working good data or good model? We cannot say that there is good data, okay? It's better if we build our good model, okay? Here why we say, okay, building a good anomaly model, this will help us to get good data and to analyze this good data in better way. This is what I mean by what is preferred, good data or good model. Good model, of course, is the answer. Okay. can cyber attack be minimized with big data analytics? We cannot ensure this, okay? We do our best. We combine several solutions to minimize the attacks, but we cannot ensure. We try our best. The new model of security in intelligence or security in depth, all of these models, okay, try to improve, to minimize the attacks and to improve security. Using data, big data analytics can help in this, and we try to investigate how much effective it is, the efficiency, the performance, and other things. Okay. Thank you, Rohani. I want to check. Your question. Okay, this is a good question, Rohan. It's not an easy. Okay, intrusion detection system, we can improve them by machine learning using this type of data, but we cannot ensure that such an improvement can be done effectively. I hope I am clear in my answer. Okay. How to get that set for performing any IDS algorithm? This is a challenge. You can find some data sets on the internet, but they are, for example, IKD, it's available, but it's all data set. Why? Because most of the security suspicious data are related to some real IP addresses and some real services that were under attack. So anonymization is used to publish any type of data related to security. So if you are working on an organization, you can have an access by asking for permission for some monitoring of the traffic, and also the network administrator will ensure to anonymize some important part of data. So usually to build this system, for example, here, what we do is build, let's say, our synthetic data that simulate real traffic. Okay. Then we, after proving this, for example, what we do after using synthetic data, we prove our system. Okay. Then we show, contact our network administrator in order to show how we can collaborate to improve their security. This is MapReduce is give you a flexible. Okay, some other things, for example, limits you according to query language, but MapReduce can help give you flexibility to manage how to process data, because the data, as we go, it's a variety of data. There is different type of data, different forms. If MapReduce can overcome this and give you flexibility, otherwise you have to normalize your data to common form to be used in other tools. Okay. Good. Now we reach to the end. As you can see here, I put my email again also. For any other question, if you would like to have any other, so you say, what is ETL process? Several abbreviation have the same meaning. Okay. This is my email address. If if you are looking for other questions, we can keep in touch using this email. Thank you very much.
We hope all the queries from the participants have been solved. Thank you, sir, for enlightening us on the concepts of big data analytics and for highlighting the current information security dilemma, along with touring us through the evolution of information security. We indeed need to increase the velocity of our research into optimizing and securing the massive amounts of data through collaboration with intelligent intrusion detection systems. It was a highly informative session, sir, and it will indeed benefit our audience. Thank you once again. I would now request my colleague, Ms. Sweta Patil, to propose a vote of thanks.
Thank you very much all. Have a nice day.
Thank you, sir.
Thank you,
you.
Kajal ma'am. Thank you, sir. I, Ms. Sweta Patil, now take this opportunity to give vote of thanks and put all my gratitude into words. I would like to thank our eminent speakers for the day, Dr. Ukukos for an informative session on IoT solutions in COVID-19, and Dr. Hani Kusa for an interactive session on big data analytics for collaborative defense. Sir, we are very grateful for the time and effort you both took to share your knowledge and experiences with our participants. I take this opportunity to thank everyone involved in making this webinar a success. A successful event has many hands working effortlessly for months. A very big thank you to our Principal Sir, Dr. Shrikant Sawant, Chief Education Officer, Dr. Mrs. Mala Kharkar, and Chief Coordinator, Dr. B.M. Rai, and all management members for supporting us and giving us the opportunity to conduct the event. I would also like to thank our BSc IT Coordinator, Mrs. Mokshita Shetty, our co-coordinator, Ms. Kajal Singh, and BSc CS Coordinator, Mrs. Namrata Kawle, for their constant guidance and encouragement. I thank all ITCS faculties involved in making this event a huge success. Special thanks to Ms. Rihana ma'am and Ms. Neha ma'am and our technical team, Ms. Rasika ma'am, Samir sir, and Karishma ma'am. I would also like to thank our students, Mr. Paras and Mr. Yogesh, for their creative ideas and design. Last but not the least, thank you to all the participants for enthusiastically participating in the event. We look forward for continued association for years to come. Before I conclude the session, I would like to give a few instructions to the participants. The feedback link has been posted in the chat box, and the link will be active for next 1 hour only. So please give your valuable feedback. The participants will also receive e-certificates on their respective mail IDs within 4 to 5 days. So with this, I conclude with the session. Thank you everyone once again. Stay home, stay safe, stay connected, and keep learning. Thank you everyone. The feedback link, once again, the feedback link is active for 1 hour only. So please give your valuable feedback.